guys, this is lesson 2.8, literal equations and dimensional analysis, aka unit conversions that you already did in physical science. And you can find this lesson on page 126. I'm going to work some examples for you on page 128. Please have your textbook and follow along. Basically, literal equations is a fancy way of saying we're going to just rearrange formulas. We're not solving for any answer. We're just changing the order of things, and we're following rules that you already know. So you already actually know how to do these things. You're just going to have to broaden the way you look at stuff so that it doesn't seem too weird to just move around letters and numbers and not actually try to get an answer. There's a really good use for this later on, especially in physics. Sometimes we just need to rearrange a formula for the way we use it, and it's part of speaking math language. So in number 1, we have 5a plus c equals negative 8a, and they want us to solve for a. So that just means get a by itself. On one side or the other of the equation, we need the whole thing equals a, or a equals the whole thing. So the first thing I'm going to do is I'm going to try to get my negative 8a and my 5a together. It doesn't really matter whether I add 8a to both sides, although it'll feel a little weird if I get 0 over there on the right, or if I subtract 5a, and I'm just a little more comfortable subtracting 5a, so I'm going to do that. Notice that's just the subtraction property of equality. Canceling out here, I get c equals a negative 13a. I want to remember that I want a by itself, so I'm going to divide by negative 13 to get the negative 13s to cancel. Don't worry about it, what it looks like on one side or the other. This is actually the answer, c over negative 13. Just for your information, c over negative 13 is the same as negative c over 13. It's also the same as a negative out to the side, c over 13. So we can write it any of those ways, and if we want to, we can flip this whole equation around. A equals negative c over 13. I just like to keep that negative any way I can so that I don't lose track of it.
Example 2 says 7h plus f equals 2h plus g, and we are going to rearrange this so that we have g equals, or it's fine if everything ends up on the left instead and everything equals g, because we can just switch which side things are on. Okay, so if I'm looking at this plus g on the very end, I have this 2h that I'd like to get rid of, and so I'm going to subtract that, minus 2h, and this will cancel on the right. And over here, notice that there are some like terms that I can combine that minus 2h with. 7h minus 2h is 5h. Literally, we have 7 h's, and we take away 2 h's, so we have 5 h's left. 5h plus f equals g, and we're done. We can rearrange it. G equals 5h plus f, and we have a nifty rearranged formula that just states the same information, but just in an order that might be friendlier for what we're trying to do. Maybe we have information about h's and f's that we can just keep plugging in, and then we'll just calculate that and get g every time. And it's maybe going to take too much time to keep solving it in this original form where we would have to rearrange things every time we tried to solve it. Okay, the next one we have k plus m over negative 7 equals n, and we really wanted k. So we're going to have to get rid of everything other than the k. Let's deal with the bottom of the fraction first. We have divided by negative 7, so let's multiply by negative 7. I would write that a little higher, but my number 3 is in the way. Think of it like that, right? So that we're canceling just like that. We have to do that on the other side. We're going to times negative 7. So I now have k plus m equals a negative 7 times n. I like it looking like this a little better than n times negative 7. Means the same thing. Remember that we're solving for k, so we want to get rid of plus m now. I'm going to go minus m on both sides, and now I have k equals negative 7n minus m. And that's my answer. I just wanted an equation that was k equals instead of k plus m over negative 7. equals n. All right, in example 4, we want to solve for p when we have q equals p times r plus s. Because it's p times, to get p by itself, what I'm going to do is actually divide by r plus s. I'm thinking of this as a chunk, as a one particular factor that can be canceled. So I can cancel that factor, and I just have p by itself. If you were to use the distributive property now, that's hard to say, you could get PR plus PS, and then notice you have P as a variable in multiple places. That's not helpful. All right, let's balance this out. We must do what we did on the right over here on the left, and this is actually our answer. Q over R plus S equals P. Don't stress it. You just want that Q over R plus S. That's exactly what you need. You can flip this around. P equals Q over R plus S. It's exactly the same thing. And you'll just do whatever suits what you need in your scientific experiment or in your data exploration or whatever is happening. Okay, number 5, it says a soap company wants to use a cylindrical container to hold their new liquid soap. Solve the formula for H. So you have to look at the picture there and see the cylinder, and we see that volume equals pi r squared H. And we want to get H first so that we can talk about the height of our cylinder. Maybe we want to see how making it taller affects the volume, or maybe we want to see how making it shorter affects it. It just depends on what information we need, and we need to be able to speak math enough to get the information to work for us. So in this case, we're trying to get H by itself. This actually looks way messier than it is. This is just pi times r squared times H. So you have 3 things times together. We're just going to divide by all the things we don't want. We're going to divide by pi, and we're going to divide by r squared. So we will cancel the pi's and cancel the r squareds, and then H will be all by itself. So we just got to go over here on the left and do exactly what we did on the right. So now we know that volume divided by pi r squared equals H, or H equals volume divided by pi r squared. All right, let's play with the B part of this problem that actually lets us throw in some units. What is the height of a container if the volume is 56.52 cubic inches and the radius is 1.5 inches? And then we're going to round to the nearest tenth. So, height. What do we want the height to be in? We want the height to be in inches in the end, right? We do this in physics all the time to see if we're going to get the right answer, to see if our setup is going to work. Okay, so height equals, and then volume is 56.52 cubic inches. I'm going to put that in here so you can see it, how it works out. And then on the bottom we have pi, that's it's a constant here, and then times the radius squared, so we have 1.5 inches squared, or it's going to be squared. Let's go ahead and, well, here, let's write it like this first. All right, so when we actually, 1.5 times 1.5 is 2.25, so let's write this like this. 56.52 inches cubed over pi times 2.25 inches squared. See how that worked out? Here I did 1.5 inches times 1.5 inches to get the 2.25 inches squared. We probably actually could have left it broken out. So here's what I wanted you to see. 56.52 inches cubed means this: inches times inches times inches. Did you know that? This actually, the exponent here does the same thing it would do on a number, and we get inches times inches times inches. That gives us our 3-dimensional volume over pi, no unit on pi, times 2.25, and inches squared means this, inches times inches. That's an area, and that's a two-dimensional unit. So what happens is inches cancels with inches, and inches cancels with inches, and we're going to end up with 1 inches unit left over. And the coolest thing about that is that's exactly what we wanted our height to be. So we know we're going to get the right answer because we've set it up right. This is like the key to physics. I'm not joking. And if you don't think you're close enough to physics yet, physical science is pre-chemistry and pre-physics. So you'll be dealing with it just enough that any insight is useful. Okay, I'm going to do this math. We have 56.52 divided by, I'm going to put parentheses around this, pi is a shift key on my calculator, times 2.25 end parentheses equals. So I get this 7.995944341 yada yada. And I was supposed to round this to the nearest tenth. Up, look what happens. This guy's going to round this guy up, but rounding this guy up makes it a 10, so it actually goes to here, and we're going to end up with 8.0. We'll put that 0 because we wanted tenths, inches. All right. Let's look at another dimensional analysis problem. Scott found a rare video game on an online auction site priced at 35 Australian dollars. And we want to convert that to US dollars. We know that 1 US dollar is 1.24 Australian dollars. Okay, so we have 35 Australian dollars times 1 US dollar over 1.24 Australian dollars. And I put it in that order. I could have flipped it the other way, but I want to cancel Australian dollars and get US dollars. So 35 times 1 on the top, and we're going to have that 1.24 on the bottom. Do that math. 35 divided by 1.24 gives me 28.225, so we'll say 23 because we're talking about money, and that is US dollars. All right, one more of these. We have a fisheye lens, has a maximum focus range of 13.5 centimeters. 1 centimeter is equal in length to 0.39 inches, and we want to get all the way to tell what this would be in feet. So let's put things where they belong. I actually like to connect my fractions in a row like this, just so they don't end up wandering all around, but it does the same thing as if you wrote them all separately. Okay, why did I do that? Because I want centimeters to cancel. Now I have inches, but I want feet. What do I know about inches and feet? I know that there are 12 of them in 1 foot, and so I can cancel inches. And again, just like the last problem, I know my setup is going to work if I can cancel out all the units I don't want, and then I'm going to get the one I do want. So I'm doing on the top 13.5 times 0.39 is 5.265, and on the bottom I'm going to divide that by 12. Divided by 12, I can do this all in my calculator. I get 0.43875, and the problem, well, just probably wants that, so I'm just going to leave it right there. That's how many feet. All right.